Hello everyone, welcome to Environment Technology NewsHour. Sawadee krap, namaskar. This is, as you know, this is a weekly program on environmental technology and happens on every Tuesday. And as you know, this is organized by the TechnoBase. Let me brief you about TechnoBase. What is TechnoBase? What kind of services we offer? TechnoBase is established in 2005. It is recognized as International Resource Center for Industries and Technologies. Our fundamentals of the business is focused on the two things. We offer professional education and also we offer the business and networking services for the various industries and technologies. When it comes to the services, we organize exhibitions, we organize technical training programs and conferences, we have webinars, business networks, we have a talent search, knowledge test, technical consulting, and also we offer integrated marketing, and also we have this NewsHour program. Okay, and with along with that one, we also have various publications. When it comes to the industry or business focus, we have a broad spectrum of the industry. We call it a polymer and process technologies. We cover on the polymers, we on the rubber, plastics, polyurethane coatings. We also have on the technology side on the chemical engineering, energy environment, water membrane technologies, filtration, separation, advanced materials and process technologies. So this is a broader focus of the TechnoBase activities, but our services are pretty much global, offering the broad spectrum, whether it is engineers, technical people, and also the business owners also we offer the services. So we are here for the Environment Technology NewsHour. Okay, and we are on episode number 5, and I welcome you all for this the session. Today this episode is focusing on the biogas cleaning, and the topic is a BTS-MP dry technology for biogas cleaning. And this presentation will be given by Dr. Joaquin Reina Hernandez. He is owner and founder of the Biogas and Gases Technologies based in Spain. Let me brief you about Dr. Joaquin. He's a specialist with 20+ years experience in energy recovery from waste. As I mentioned, he is a founder of the Biogas and Gases Technologies, and also is a founder of Energy and Waste Engineering. He has completed more than 15 biogas cleaning projects working in South America, North of Africa, and in Spain, including the first biomethane plant of the Spain. As you see, Dr. Joaquin has a good experience on the biogas cleaning, and it's a good opportunity for all of us to learn about this technology on the BTS-MP dry technology for biogas cleaning. So let's invite Dr. Joaquin to make a presentation.
Good morning, everyone. Thank you to all for attending this Environment Technology NewsHour. Let me first introduce myself. My name is Joaquin Reina Hernandez. I am founder of the Biogas and Gases Technology. This company is located in Barcelona, Spain, and involved in projects like biogas cleaning, biomethane production, odor removal, and waste treatment in general. I would like to present, in this case, this topic, the biogas cleaning. And inside of the biogas cleaning, I would like to show the BTS-MP drive technology, this biogas treatment system, multi-purpose dam based on dry system, on dry technique. Technology for biogas cleaning is the development made by our group here in Spain. Okay. This is the indice that I want to present to all of you. Introduction, topic development, and with all this knowledge, see the case study. In this case, the Butarque wastewater treatment plant here in Madrid, one of the successful projects of our company. The result to apply this technology in this facility, and at the end, the conclusion of the projects. What can I say to introduce this topic? Biogas production or biogas plant or biogas facility has three main parts: biogas production, digester treatment, and biogas purification. Why biogas purification? Because the biogas coming from the digester is a dirty gas because it has many impurities. And if you want to use this biogas for energy production or for another product production, you need to purify this biogas and remove all the impurities. Here, what is the biogas? There are many definitions about biogas, but for the people, staff, engineering, or group that working on application or use the biogas, biogas is a gas mixture that has two main parts. One part related with the major component, methane, CO2, nitrogen, oxygen, and so on, and other part that are the impurity, in this case, the dangerous component or pollutant for use, hydrogen sulfide, silosa, water vapor, hydrocarbon, and all these traces are dangerous for the biogas application in any field. Therefore, the biogas is considered always a dirty gas that requires prior cleaning for use as raw material for energy production or for another product production too. Currently, we can find or we can talk about two kinds of biogas. Biogas coming from control process, for example, landfill, lake, or swamp, and biogas coming from control process, for example, wastewater treatment plant, agricultural waste, industrial waste, and so on. In this table, you can see the difference between their composition depend on the origin of the biogas or source of production from control process and control process. As you can see, the biogas coming from control process have level methane, low CO2, high level of hydrogen sulfide, and in some cases, silosa. However, the biogas coming from control process, like landfill, for example, have level low of methane, high level of CO2, high level of nitrogen, high level of oxygen. In some cases, appear hydrogen sulfide and high level of hydrocarbon of both types, of both kinds. Heavy hydrocarbon and light hydrocarbon. What kind of impurity we can find in the biogas stream? We can find generally two types of the impurity in the biogas stream: external impurity and internal impurity. External impurity not belong to the biogas loop. For that reason, they are not part of the biogas loop. This must be fair in removal by mechanical operation like filtration or change in fluid direction or dimension. In this impurity, we can find sediment, foam, particle, condensate, and so on. This kind of cleaning we define as growth removal, and is useful for defining the biogas fluid. The internal impurity that are part of the biogas fluid are usually the last in removal by chemical, physical, biological, or combination of this kind of technique. And inside of this internal impurity, we can find water vapor, siloxane, hydrocarbon, hydrogen sulfide, ammonia. And this kind of cleaning we define of fine removal and in some cases polishing. What are the effects of the different impurity on equipment or machine involving in this kind of the application of facility? For example, water vapor or humidity, hydrocarbon. Here appear in the screen the different effects. Water vapor reduce or decrease the low heat value of the biogas, allow the accumulation that cause blockage and in some cases ice formation, mainly when we in the winter season. Yes, hydrocarbon halogenate, mainly that have chlorine and fluorine, that provoke corrosion in different parts of the machine. The heavy hydrocarbon that provoke the presence of aldehyde in the gas, in the fuel gas, and provoke to bad working on the machine. Hydrogen sulfide that provoke corrosion in engine, in machine, formation of another acids, and pollution of the lubricant oil. While siloxane provoke, in this case, inlay on engine internal part, increase the currents between moving part and feed part, and lose the lubrication oil. What are the current techniques appear in the market for biogas cleaning? A specific technique, general technique, or combined technique. A specific technique, removal only one component. For example, for hydrogen sulfide removal, or for water vapor removal, or for siloxane removal. In this case, for example, for hydrogen sulfide removal, there are many techniques, biological, chemical, and physical technique. For example, biofilter, iron filter, chemical scrubber, biochemical scrubber, water vapor, for example, dryer, condenser, condensate point, absorption silica gel, and for siloxanes, for example, there are two mainly equipment appear in the market, that are membrane system and silica gel absorption. In the general technique, for example, we can find the absorption of active carbon because the carbon has the possibility to get to capture different components. For example, at the same time, siloxane, halogenate hydrocarbon, hydrogen sulfide, humidity, and so on. And combined technique in working on simultaneous or by state, for example, drying and active carbon, like our technology, BTS-MP dry, and desulfuration, plus drying, and so on. One must be part of the biogas cleaning facility. From our point of view, there are three main parts of the biogas cleaning technology: biogas desulfuration, biogas drying, and biogas polishing. Biogas desulfuration depends on the biogas type, or the origin of the biogas. Could be in source, for example, or in origin, on digester, on the over the material to be treated, for example, in wastewater treatment plant, by chemical dosing, oxygen or air injection, thermal or biological hydrolysis. In the case that the desulfuration will be in the biogas line, for example, like wastewater treatment plant, landfill, and so on facility, by physical, chemical, biochemical, or biological technique, you can do it, this removal. Biogas drying, in this case, is the aim to remove water vapor, but in this case, if you when you use biogas drying, if you working at low temperature, for example, down of the 4 Celsius degree, you can remove at the same time volatile organic compound, hydrocarbon, and siloxane. And in this case, you can combine condensation and drying technique. And biogas polishing, always we recommend this kind of cleaning is for by active carbon, or is for removal the trace of pollutant that appear yet in the biogas flue. Okay, I want to show this case in brief well, the case of a study, the wastewater treatment plant Butarque in Madrid, Spain, with our technology, BTS-MP dry. Here is the wastewater treatment plant Butarque, digester, gas holder, and down you can find our technology. Let me explain more or less how work in this technology. This technology has two parts. The one part is the cooling system, yes, this, and the other is the polishing system by active carbon. In this case, in the cooling system, appear at the same time two ways of cooling. In this case, we use and recommend they use, in this case, the heat recovery, okay? And other part is the cooling system. In this case, the exchange is between hot gas with cooling gas, and in this case, is the cooling water with biogas. In this part, that is very important for us. There are two kinds of the cooling system: thermal system in this zone, and the mechanical cooling in this system, which include condenser and droplet. In this case, is the cooling biogas exchange heat with the hot gas. With this system, we reduce the power or the energy consumption of the chiller, and at the same time reduce as the relative humidity the biogas. For that reason, the biogas get into the filter with a good condition to submit at the absorption process. Here appear our technology. Okay, here screen, control screen, filter, cooling system, and chiller. Economizer. Let me explain in a little the economizer. Our point of view, we recommend they use the energy recovery for biogas flue higher than 500 normal cubic meter per hour, and for temperature higher than 40 Celsius degree. At least in our experience, we with a good design of this equipment, we allow recovery up to 30% of the energy of the drying system. Therefore, the OPEX of the drying process is reduced. What are the conditions that I use for operation of this technology? In this case, appear this chart, when the appear the temperature here and appear the water vapor contained by normal cubic meter. We go for 30 Celsius degree to 2 Celsius degree working temperature. Okay, in this case, we remove 35 grams of water vapor for normal cubic meter. But at the same time, we relate with this kind of the chart too, we can remove up to 40% of zero sand, yes, when we were at this temperature. That's it. At the same time, we remove water and we remove one of the main pollutants appear both in landfill gas and in the wastewater treatment plant. What is the result of this? The first result is reduce the silo sand in the biogas in all cases, and at the same time reduce the silicon in this type. This is the result before BTS and after BTS use or application. And what is provoked this? This provoked that the concentration of this the silicon mainly in the oil, in the lubricant oil in the engine reduce low than the 10 ppm. For that reason, the maintenance cost reduced at the same time. At the end, this is the result to application this technology for biogas cleaning for use in the energy production. Here, you can see the profit behavior by the biogas cleaning. The orange behavior belong without BTS use. The blue behavior belong to the with BTS in the biogas facility, and the yellow color is the saving. As you can see, around 10 years, the amount, as you say, that it allows any group or any company to buy a new combined heat and power system again. For that reason, the conclusion of this presentation of this case study is the optimal machine working, an engine, turbine, boiler, vehicle, reduce the maintenance cost, the long useful life of the machine and equipment using for pumping, compression, blower and compressor, in this case using the biogas transport, and improve in the exhaust gas emission of engine, turbine, and steam boiler, and say the staff work due to the avoided toxic concentration to the human. Thank you for your attention. I am available for any comment, any idea, any question, any doubt.
Okay, thank you, Dr. Yudkin. It's interesting presentation on the biogas cleaning. Let me take over. Okay. I'd like to ask you a couple of points for you to explain me more. In your system, the first section is removing the vapor is the first thing. Is it right? Water vapor is the first thing to remove.
Yes.
Okay, and before after that we have that you know, any dirt or is which is the first goes, the water vapor is first to remove, and then the any solid particles, right? And by changing the flow, is it correct?
Yes.
Okay, and after that you go on the cleaning on the in terms of hydrogen sulfide or, you know, hydrocarbons and things like that. Yeah.
Yes. Yes.
Right.
We recommend, due to the impurity appear in the biogas flue or in the production of the biogas in any facility. The first is removal the external impurity like sediment, foam, particle, condensate that form part of the stream of the biogas stream, but not the biogas flue. With this kind of cleaning, this is the externally removed with gross removal to remove external impurity, we define the biogas flue. And after we define cleaning, remove the internal impurity like water vapor, siloxane, hydrogen, okay? In this case, our technology, our technology is focused on mainly in the fine removal and fair removal, water vapor, and according with the temperature condition in the outlet of the biogas, in this case, 2 Celsius degree, we remove at the same time not only water, remove siloxane, some kind of the traces of the sulfur, hydrogen sulfur, hydrocarbon, and so on. And in this system, prepare at the same time the biogas to get into the absorption process, because the absorption process is very sensitive and many impurity.
And your efficiency, system efficiency, how much to remove the hydrogen sulfide or hydrocarbons? What is the removal efficiency?
95%, 97% or more. Minimum 99%. Okay, as you can see in the table. In this case, this facility in the Butarte wastewater treatment plant, the aim of the application is removal siloxane because there are many problems with the engine due to appear the siloxane in the biogas flue.
And your experience, you have, there is a controlled process and uncontrolled process. Yeah. And you said you have 15 some projects you did on the biogas cleaning. Which segment is it? Is it more on the uncontrollable, like landfills, or you did more on the controlled wastewater treatment? Which project on 15 projects?
In both cases, I have been working in both cases, in landfill and in wastewater treatment plant. And I would like to say that we start with the biogas cleaning working on landfill here in Barcelona. But they are, as you can see in the table, mainly in the composition, they are a big difference. Yes. Not only in composition, sino including two in the process. Yes. For example, in the control process, the process that domain that is general is the anaerobic digestion. Okay. However, in the landfill is a combined anaerobic digestion with aerobic digestion. Right. For that reason, appear oxygen, appear nitrogen in quantity or high level. Okay, this no appear in the control process because what have only a step anaerobic process. Yes, and not allowed to introduce or appear oxygen or air, in this case in the internal inside of the process. Sorry.
And in your experience, in particular the landfill, is it difficult to implement the project?
Yes, difficult to implement the projects.
Implement, the project execution, in terms of the because the landfills is not really controlled manner. Operations are not controlled. Yes, yeah, and also the composition of the gas vary a lot. right? The
Yes.
that is it any effect on your operations because of variations of the gas composition?
Could be affected, but not much. Not much, because this kind of technology apply only in the biogas line. Okay, the unique control that appear or they are in the biogas coming from of a landfill is the is the control of what are the hell is produce a good quality of biogas. There are many helps here or around the sulfides of the landfill, and only some wells are produce a biogas with high quality, and in this case the unique control is the quality of biogas and the pressure for extract this biogas. Okay.
And you have like a monitoring system, like a display, how much is the removal efficiency, the gas flow. You have like some kind of panel to see how is the system performing?
No.
Okay.
No. Our panel control is mainly for control parameters of the process. But if our client asks us, I need more control, we can put sensor to measure the biogas composition after biogas cleaning and before biogas cleaning. Yes, and so on. But the only control is the control based on the technology, temperature, okay, pressure.
Okay, and you have experienced in North Africa, right? You did some project in North Africa. Can you tell about your experience there? What kind of project you did in North Africa?
Yes. We have one experience in North Africa. In this case, in Tunisia, in wastewater treatment plant Nabeul, was here a company that developed this project and asked to us, we need to biogas clean. We have a problem. We need that you supply the equipment for the biogas cleaning, and we in this case we supply not only the BTS, in this case the biogas cleaning facility. We supply another equipment for the gross removal, sediment, foam, and particle and water vapor, and condensate.
And the H2S composition, which is much more dangerous than any other impurities, right? In H2, in hydrogen sulfide is the most dangerous impurity, which impacts the gas engine also,
Yes. For me, our point of view, the most dangerous pollutant is the hydrogen sulfide, because this kind of pollutant affect the environmental and the technology and the people. Right. And one thing that I to be into account in this kind is that we handling this technology are the people. For that reason, we take care to the people, and for this is need. I always recommend fair removal all quantity, in major is better, the hydrogen sulfide fair, which kind need. Yes.
Yeah. I know. I understand. If you don't take care of the hydrogen sulfide properly, the project will be in a big trouble. Okay, particularly in the
Yes.
energy. And if your project is focusing on the energy recovery, getting rid of the hydrogen sulfide is very, very important. So
Yes.
okay,
Yes.
so can I ask you one final point? How much it costs, this system? Is it expensive?
More or less, depend on the biogas flow,
Yeah.
the condition of the biogas flow, and the pollutant composition. How many impurity must be removed?
Yeah.
Okay, and depend.
Okay.
For example, the wastewater treatment plant in Mexico at Totonilco, yes, the most bigger project that we do, around the cost was 2 million. But the flow is 14,000 cubic meter per hour of biogas.
Wow. Okay.
In this case, we use 5 facilities of biogas cleaning, and each facility treat around 250 normal cubic per hour of biogas.
Oh, okay. Wow. So how much energy they produce that plant? How many kilowatts?
28 megawatt.
Wow. This is a government. It is a government project. Is it a government?
Very big. Yes, very big project.
Okay. Yeah. Okay, thank you, Dr. Joaquin. It's really interesting presentation about your technology, and I think everybody, who has wastewater treatment plant with biogas, they should use the cleaning system. Then only they really benefit. Yeah. So, any final comments to the audience? Final remarks to the audience, please. Yeah. Do you like to say thank you? Yeah.
Thank you to all for your attention or for giving me this opportunity to present our technology in this kind of event. For me, it's a pleasure. Could be can present this our equipment and our service for any kind of facility, in this case biogas, in this case in any country, in any company. Okay, thank you for this opportunity, and thank to the people that are attending this Roman Technology New Software. I am very glad for this.
Okay. Thank you very much. Thank you, Dr. Joaquin. It's a really interesting presentation. Thank you very much.
Thank you very much.
Yeah. Okay. Guys, that's the end of the presentation on the biogas cleaning, and I'm hoping that you find it useful. Okay. Presentation on the BTS-MP dry technology for biogas cleaning by Dr. Joaquin Reina Hernandez. He is the founder of the Biogas and Gases Technologies based in Spain. As you can see, he has an extensive experience. If you wanted to reach out to him, you can contact him. And you can also reach out to us so we can coordinate for you as well. Yeah, that's all the presentation on the this topic. Okay. If you are interested to view this this program again, you can always check on YouTube at Technology channel. Please check for the not only this episode or even the past episodes also you can view it. Yeah? If you need any assistance from us, you can reach out to me or my colleague. Okay? Both of us are available to assist you for any additional support you need for this environment technology news server. Okay. Thank you all for joining this session today. I see you in next episode. Bye bye for now.
Bye bye.